In this lecture, we will discuss the basic methods available for analyzing statically indeterminate structures and methods for computing deflections. A quick recap of analysis. So, two basic methods available for analyzing statically indeterminate structures. The first one is compatibility method, is also known as force method, flexibility method. So here redundant forces are taken as unknowns. Additional equations obtained by considering the geometrical condition imposed on the deformation of structures. This method is simple if the structure has lesser static indeterminate. However, this method is not suitable for computers, somewhat difficult to computerize. The methods which are under this compatibility method are method of consistent deformation, free moment theorem, column Anlagi method, elastic center method, Castigliano's theorem, flexibility coefficient method, etc. The second classification is equilibrium method. It's also known as displacement method or stiffness method, because this method involves displacement as unknowns and the stiffness coefficient used. That's why the name. So displacement of joints as unknowns. So equilibrium equations are expressed in terms of these joint displacements. And it is best suitable for computer or computerized. As an example, there is methods which are coming under this equilibrium method or slope deflection method, moment distribution method, minimum potential energy method, stiffness coefficient method, etc. The choice between force and displacement, that is compatibility and equilibrium method, depends upon the type of the structure and its support condition. And considering the methods for computing deflections, we can classify those methods in two categories. One is geometric method. So it is based on a consideration of the geometry of the deflected shapes of structures. Example, direct integration method, superposition method, moment area method, conjugate beam method, etc. The second category is work energy method. It is based on the principles of work and energy. Example, virtual work method, strain energy method, Petty's and Maxwell's law of reciprocal reflection. Now we will study about strain energy method. The energy of a structure is actually defined as its capacity for doing some work. And the term strain energy is attributed to the energy that a structure has because of its deformation. The relationship between the work and strain energy of a structure is based on the principle of conservation of energy. So the principle of conservation of energy is stated as the work performed by gradually applied external forces on an elastic structure is equal to the work done by internal forces or the strain energy stored in the structure. That is, WE is equal to WE, work done by external force is equal to work done by internal force, which is equal to strain energy. Now we will look at the expression for total strain energy of various structures. The first one is truss. So the total strain energy of a truss is expressed as U is equal to sigma of F squared L. Sorry, here F squared L, not FL squared. F squared L divided by 2E, where F is the member force, L is the length of the member, A is the cross-sectional area, E is the Young's modulus. Next, strain energy of beams. Here we consider only bending, not shear force and axial force. So the strain energy of the beam in bending U is equal to integral of 0 to L m squared over 2 EI into dx. Okay, because strain energy stored due to shear as well as axial force are very small as compared to the bending moment, we ignore it. Next, strain energy of shapes. Here we have both axial force as well as bending. If we want total strain energy, we have to add both. But if the members are rigid and inextensible, so we can ignore the strain energy due to axial force. We can consider only the bending strain energy. So this is the expression for strain energy due to bending. Now Castiglione's second theorem. For linearly elastic structures, the partial derivative of strain energy with respect to an applied force or moment is equal to the displacement or rotation of the force or moment along its line of action. This is the statement for the Castiglione second. Mathematically, it can be referred as dou u by dou pi is equal to delta I, or dou u by dou mi is equal to theta I. Now Castiglione's theorem of least one. It is stated as the work done by redundant reaction components of a statically indeterminate structure is minimum. That is dou u by dou ri is equal to 0.